5-2, radical expressions. You will be able to write equivalent radical expressions. So you would need to know what your perfect squares are. Perfect square is any number that's able to be square rooted. It's a number multiplied by itself. So there's two ways to do this. There's finding a perfect square. So here's a little list of your perfect squares from about, so you have 2 times 2, 4, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10, 11 times 11, 12 times 12, 13 times 13, 14 times 14, 15 times 15, 16 times 16, 17 times 17, 18 times 18, 19 times 19, and 20 times 20. Those are your perfect squares. If you're able to square root any of those, it comes out to be a whole number. So, easiest way, my thinking, is to find two numbers. One of those numbers has to be a perfect square that when you multiply gives you 63. So, one way that you can do this is 63 would be somewhere between 49 and 64. Then go down till you find that number that can go into 63. Can't be 49, cannot be 36, can't be 25, can't be 16, 9. 9 is my perfect square that can go into 63 times 7. Since 9 is a perfect square, you can type this in your calculator, square root it, a 3 comes out. There is no other perfect square that can go into a 7, so 7 stays inside the radical, and this would be your simplified expression. There is nothing else you will be able to do with this problem. If that confuses you, you can do a family factor tree. For example, 63, you can start breaking it down any way you want. You can start small. 2 can't go into an odd number, so you can start with a 3. 3 times 21. Keep breaking it down until all your numbers are prime. So here I have 3 squared times 7. If I would put that inside the radical, that gives me 63. Since this is a square root, anything that has a square can be taken out of the radical. So 3 squared can be taken out, and 7 can be left inside. It does not have a pair. So if you notice, both answers come out to be the same. Letter B, they kind of already did the factor tree for you. I like to do, if it's a square, I need pairs. So I'm going to make my 2's all into pairs. I have 2 squared, another 2 squared, one more, and then I have a lonely 2 that doesn't have a partner. 2 plus 2 plus 2 plus 1 is your 7. And then a 5 squared. So anything that has a pair will come out of the radical symbol. So 3 2's are coming out, and a 5 is coming out. This 2 does not have a square, cannot come outside, it has to stay inside. Multiply everything that came out. 2 times 2, 4 times 2, 8 times 5, 40. So your final answer for this would be a 40 radical 5. Here are some try it if you want to pause and try on your own. Here we have 44. Actually, I'm going to do 44 over here. Again, you can go back to that list that we had and try finding what two numbers when you multiply gives you 44 with one of those coming from that list. 4 times 11. 4 is my perfect square. I can square root it and a 2 comes out and 11 stays inside. If you like the family tree, 2 times 22, 2 times 11. I have a pair of 2's and I have an 11. That pair of 2's comes outside, 11 stays inside. Whichever way you like, do it that way. Here, I can, what two numbers when I multiply give me a 27? One of them being a perfect square, 9 times 3. Square root of 9 is a 3. It comes outside, but you already have a number on the outside. So those two numbers have to be multiplied together. Gives me a 9, and that 3 stays inside. Again, my family tree. 27, 3 times 9, 3 times 3. Group them in pairs. You have a 3 squared and a 3 without a pair. This 3 came outside. You already had a 3 on the outside, so that 3 times 3, 9 with that 3 inside. Next here we have cube roots. So that means now we need 3 of a number in order for a number to come out. So you could multiply 45 times negative 75. It's going to be a very big number. So I would just try maybe doing your family tree from here. So 45, 5 times 9, 3 times 3, 75, 5 times 15, and then 3 times 5. Since you're multiplying, I can group them together. Positive times negative, negative. And now, since it's a cube root, I now need 3 of a number. 1, 2, 1, 2, 3. So I have 3 cubed times 1, 2, 3 5s. So the negative is going to come out, and a pair of 3 comes out, and a pair of 5 comes out. Negative 5 times 3 would just be a negative 15 as your answer. Next, when you have the same root, you can make one big fraction and see if you're able to reduce the fraction. We can go by 5 first. 15 divided by 5 is 3. And 405 divided by 5 is 81. Then I notice that 3 and 81 can also be reduced. 3 goes into itself once, and into 81 27 times. If I do my factor tree of 27, 3 times 9, 3 and 3. So I have a set of 3 3's, so that means a 3 comes out. Any number inside the radical that's a 1, whenever you root 1 to any number will always be a 1. And then since I have 3 3's, a 3 comes out, and my answer would just be a 1/3. Next here again, these are kind of big numbers, so I would do the factor trees first, especially if it's a cube root. 3 times 7, then 147. I know I can't do by 2, so let's try 3. 147 divided by 3 is 49. And then I have 7 times 7. I only have 2 3's, and I have 3 7's. So the only thing that's going to be able to come out is this 7 because it has 3, and I need to cube root it. So 7 comes out. Because this 3 could not, it stays inside, and you can just multiply the two numbers together. So 3 squared would be a 9, and that would be a final answer. Here again, you can just make one big fraction, and you can always start small. Any number that ends in a 5, always it's divisible by 5. So we have 45. 225 divided by 5 is 45. 75 divided by 5 is 15. And then 15 goes into 45 three times. So when I divide 45 divided by 15 is a 3. And 3 is a prime number, so there's nothing else I can do with this problem. This would just be left as a cube root of 3. Next, multiplying radical expressions. How can you write an expression for the product without any perfect square factors in the radicand? So you can do it separately. Again, you can do your factor trees. So you can do factor tree of 10, 2 and 5, factor tree of 120, 2 and 60, 2 and 30, 2 and 15, and 3 and 5. So 3 times 2 is 6, and then inside, so now it's a square root, so now I need pairs. I have 1, 2, 3, 4. So I have perfect even numbers. I only have 1 3, and I have a pair of 5s. So the 6 is already on the outside. This 2 comes out, this 2 comes out, and a 5 comes out. And only 3 stays inside. So 6 times 2 times 2 times 5 is 120 with a radical 3. The square root, you can also do outside number multiply with outside number. That is a 6. Inside with inside. 10 times 120 is 1,200. And then you can try finding what perfect square is the biggest that can go into 1,200. If you looked at your perfect square list and you look all the way in the bottom, you have a 400. 400 goes into 1,200 3 times. 400 is a perfect square of 20. So 6 times 20 with a radical 3. And then 6 times 120. 6 times 20 is 120 radical 3. So whichever way you guys find easier for yourself, I recommend keep doing it that way. You can pause and try these on your own. If you do have really big numbers, I would maybe try doing your family tree. 1/2 times 4 is a 2. And then 168. I can go by 4s. 168 divided by 4. 42. 4 can be 2 and 2. 42, 6 and 7. 6, 2 and 3. And then 28, 4 and 7, 2 and 2. So here I have a pair of 2s, here I have another. So 2 squared, another 2 squared, and then I have a pair of 7s. I have a pair of 2, I have only 1 2, 1 3, and I have a pair of 7s. So the 2 that's already on the outside, 2 2s come out, a 7 comes out, and then 2 and 3 stays inside, so that's a 6. 2 times 2 is 4, 4 times 2 is 8, 8 times 7 is 56, radical 6 should be your answer. Now, the second one, if you ever have big numbers, go ahead and just maybe double check to see if maybe they're perfect squares. The first one is not, but if I do 576 and I square root it, that is a perfect square of 24. So now that's a whole number. I can only multiply that with that whole number. So that makes it 48 radical 3,072. Trying to find a perfect square of this number is kind of a bit difficult. So if you want to do the family tree, you can go ahead and do the family tree and just find what numbers when we multiply give us 3,072. Again, you can start small. Divide that by 2. 36. And then again, keep going down. divide that by 2 again, 768, 384, divide by 2 again, 192, 96, 2 and 48, 2 and 24, 2 and 12, 2 and 6, and finally 2 and 3. So 1, 2, 3, 4, 5 pairs of 2s. 1, 2, 3, 4. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and lonely 3 stays inside. 2 to the 5th power is 32. So 48 times 32 is 1,536. Radical 3 would be your final answer for this one. Now we're back with the cube roots. So this would be 2. It's a big 2 on the outside. Times radical 72, cube root of 72 over 3,888. And again, let's try to reduce it. 72 divided by 2 is 36. Try to always reduce it as much as possible, just so your numbers are easier to work with. And 3888, divide that by 2, 1944. And again, we can go again. 36 divided by 2, 18, 1944, 972, you can keep going, 18 divided by 2 is 9, 972 divided by 2, 486. I can divide by 2 again. Can be this divisible by 3? Ooh, 9 this. Now I can divide by 3, and that turns into a 3 over 162. And I can then divide by 3 again. So basically, 3,888 divided by 72 would have been 54. Alright, so now, I'm just going to break down 54. 2 and 27. 2, ooh, not a 2. 3 times 9, and 3 times 3. Alright, there's going to be a little issue now. So here, there should never be any radicals in the denominator of any fraction. So, right now I have 1 over a 2 that's by itself, and a cube of 3. So I have 3 3's. That's going to come out. But I have 2 to the 1st power. I cannot leave that 2 there on the bottom. So I would need to multiply that entire fraction by something that the 2 would be able to come out. So I need 2 more 2's in order for that to be 2 to the 3rd power. So I need to multiply that by 2 squared. Whatever you do to the bottom, you do to the top. So it looks a little confusing. So I have my radical, 3, 2 still on the outside. Now I have 2 squared on the top. And now on the bottom, this 2 to the 1st and 2 squared become 2 cubed. And comes out, and that 3 comes out. So 2 squared is 4. I can't do anything with that. Over a 2 comes out and a 3 comes out. This 2 that was on the top there would cancel out with that 2. So my final answer here would just be, oops, so there's only one radical now. The cube root of 4 over 3 would be a final and complete answer. Because remember, this 2 technically is a whole number. Think of it as 2 over 1. And these 2 cubed and 3 cubed are on the bottom of a fraction, so they can't be multiplied with the 2. Technically, they're underneath the 2 as a fraction. This might be easier because it's a square root. Again, I can try simplifying this. I believe 7 can go into both of these. 63 divided by 7 is a 9, and 98 divided by 7 is a 14. Perfect. So in order for me to square root, and then you can also do it individually. If you notice that any of them are perfect squares, 9 is the perfect square of a 3. So that comes out of the radical, and 14 stays inside. But 14 is 2 times 7. As a final answer, you can never leave a denominator with a radical in the denominator. So in order for that radical symbol to be taken out, I need another 2 and another 7. Whatever you do to the bottom, you have to do to the top. So 2 times 7 would be 14. Nothing I will be able to do that on the top. Now on the bottom, a 2 squared and now a 7 squared. The 2 and a 7 is both going to be able to come out. I can't simplify 3 with a 2 or the 7. So that just becomes 3 radical 14 over 14. And no, these would not be able to be canceled out because 14 is inside the radical. This 14 is on the outside. It's a whole number. That would be your final answer. Next, sum. Sum is addition. You can only add radicals if they are alike. So they need to have the exact same radical. Radical stays the same. It's like saying 12x and a 6x. You only add the number, the coefficients. That would make it an 18x. Radicals is the same concept. If they do not have the same radical inside, you can't add them together. So that stays as a radical 7, and you would just add 12 plus 6 and make it 18. And then always check to see, can 7 be broken down? It cannot, so it stays as 18 radical 7. Let's do letter C first. What is the sum of 2 square root of 5 and 8 times cube root of 5? These do not even have the same radical, so they cannot be added together. So this is already simplified. Or you can just say prime. What is the difference? Difference is subtraction. So 10 radical 3 minus a 6 over radical 3. Let's do this first. Again, I can't add a radical on the bottom, so that's square root of 3. So I need another 3 on the bottom to make it a pair. Whatever you do to the bottom, do to the top. So that makes it a 6 radical 3 on the top. That becomes a 3 squared or a 9. A 3 comes out, square root of 9 is 3. And then I can simplify 3 goes into itself once, it's a 6 twice. So now I can subtract 10 radical 3 minus a 2 radical 3. Now they these on your own. Same radical, so 1/2 plus 4 is 4.5. Put 4.5 as a mixed, not as a improper fraction, would be 9/2 with a radical 28. But 28 can still be broken down. If you want to do it the perfect square way, 4 times 7